an award. And I have Time magazine at home, because Time magazine do what they call 30 under 30. So it's 30 influential people under 30 years of age. So he was listed as one of the 30 under 30 people for gaming. So I have that magazine at home. No, he's doing quite well. His game, see what, we studied maths together, and after we graduated, he took out a loan from the bank so he could work on games full time and just live off the loan. So I don't know, he took out whatever, 20,000, and he was living off the loan. And of course he was running out of money, so he felt that he would only have the chance to release one game, and that was going to be it, because he'd have no money left. So the game that he released, not Super Hexagon, it was called VVV. This is the game that gave him enough money so that it could be his career. So his job is to make games, like small indie games. So he's making enough money that can be his job. So he basically has two big games, V and Super Hexagon, which I have both of. It is cool. It is cool. Now, I'm not saying he got lucky, but I mean, if the game he released wasn't a success, then he would have to get a regular 9-to-5 job. So at least this way he's doing what he always wanted to do, because when I was studying maths with him in Trinity, he was big into programming and game development and things like that. So it goes to show that it is possible. But I don't, you have to be willing to, go 12 or 20 months without any income in the hope that what you make at the end of it is a success. And if it's not, then you have to have a plan B, which is either get a regular job or move back in with your parents. So it's a risk. It is a big risk for sure. But he's a nice guy.
But taking a risk sometimes is the answer.
Yes, he's a very nice guy.
Not too much.
Physics now, isn't it? Yes? Physics now. Yeah, before you use your laptop, I want to show you something. Did you bring your laptop? Remember, I asked you to yesterday. Who brought it?
Now on this class?
In the next class, I have something to show you first. Anybody here programs? Cool. Python? No, Java. Python, yeah. And C.
C is the one that I started off with.
Yeah, it's the one everyone must start off with.
Yeah.
It's just.
I expect Python though, because.
Well, no. C is a classic. It's a classic language. Okay, let me see. Where the heck is it? I did this one. I did the.
Yeah, we did uncertainty.
But did I do the lecture slides on it? I don't think so. I think I just wrote my notes, the tutorial on how to calculate it. So in this slide, it's just some terms which you'll need for your paper, I believe. I'll check it now. So we're just missing Yahya. Keep forgetting to set it up. I guess he's just not that important to me. Yeah, you heard me, Yahya. What are you going to do? Unlike my video? Right. Okay, if you can write these terms down, please. Terms which I hope you're familiar with from chemistry. Now, we should get enough maths done so that you could theoretically start the assignment of maths during the break, although I won't officially give it to you until after the break. But if we don't have enough time, I'll change 1 or 2 physics classes into maths classes so we can. Because I would like you to have the option to do the maths and the physics coursework during the break if you want to. If you don't want to, that's okay, that's your choice. I just think it's a good idea. Right, can I continue? So, are these words you heard in Lorraine's class? Yeah? Okay. So I took all the notes from this webpage. Disclaimer. Right. In order to interpret data correctly and draw valid conclusions, the uncertainty must be indicated and dealt with properly. The most important lesson I want you to learn from the labs, I say this every year, if you only learn one thing and one thing only from the labs, it's this. If your measurement does not have uncertainty with it, then it's useless. Every measurement must have uncertainty with it. No uncertainty, no good. That's the most important thing I want you to know from the labs. So if somebody says, oh, blah 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 is 2 meters, you also need to know 2 meters plus or minus 1 centimeter or whatever. No, if you have no uncertainty, then it's no good. It's useless. It's useless. And the reason it's useless is because you don't know how good or bad the measurement is without uncertainty. So if you want a good measurement, should the uncertainty be big or small? Small. Can the uncertainty be 0?
No.
No, it's not possible to be 0. But it's possible to be small. So this is if you only learned one thing from me, I hope it's that. Okay. For a result to have a measurement, to have a clear meaning, you cannot just have the measurement alone. You must indicate how accurate it is. Basically, we have 2 components. The number value, with the units, obviously you need units, obviously. And number 2, the uncertainty. So this whole slide is just making the point, you need 2 things, the measurement with the units and the uncertainty. Example, he is 1.7 meters tall, plus or minus 1 centimeter. Okay, so you don't need to write all this down, but I would like you to make some note about the importance of having uncertainty with your measurement. No uncertainty, no good. Right, so it's only 4 words I want you to write. No uncertainty, no good. I need to make a list of things to put on t-shirts. That's another one I want on a t-shirt. No uncertainty, no good. And mo uncertainty, mo problems. I have 99 problems, but uncertainty is not one of them. It's endless.
I have 99 problems, but math is not one of them.
Yes. It's such a problem, it's 2 of them. No. Okay. Continue? Right. Now, the true value cannot be absolutely determined. You can never really know the true value of anything. Right? You can never really know the true value of anything. Why not? Well, because we just said it's impossible for the uncertainty to be 0. So you can never know the true value. In practice, though, there's an accepted reference value. So I'll give you an example. In chemistry, you would have used Avogadro's number, right? Now, where do you get Avogadro's number? In the formula book. Is this the exact answer? No, because you can never know what the exact value of Avogadro's number is. But there is a value which everyone can use that's good enough. This is called the reference value, or I think in chemistry you call it the literature value. Yeah? Yeah. Or theoretical value, yeah. The accepted reference value is usually established by repeatedly measuring some traceable reference standard. So basically, how did they get that reference value? By doing something many, many, many times over many, many years. The value is not the reference value that is found published in a reference book. Such reference values are not the right answers. They are measurements that have errors associated with them as well, and may not be totally representative of the specific sample being measured. So, in other words, all this is saying is that it's not a perfect value. Now, I know you said theoretical value, but I feel like that's a tiny bit different, because the theoretical value of something could be exact, because it could just be a value produced by a formula. Yeah, but you can't really have any formula that produces Avogadro's number. You can only get it by doing experiments. You know. Okay, so what do you need from this? Really, I think it's kind of enough just with the first sentence is my point. The true value cannot be absolutely determined, this means calculated. In practice, an accepted reference value is used. Yes? So, since the true value cannot be determined... Oh wait, that was just repeating? Okay, for some reason I have this slide twice. I don't know why. Right, so some more definitions. Accuracy. Is this the term you did with Lorraine?
Yes.
Yeah. So, it's how close you are between the measured value and the true value. So, for example, if Andrew is 1.7 meters tall and I say he's 1.8 meters tall, then I am not accurate. If he's 1.7 meters tall and I say he's 1.705, then I am accurate, because I am close to the true value. You understand? No? What is your height? Do you know? 158. So if I say you are 158 centimeters, I am accurate. If I say you are 148...
No, 17.
Okay, fine. If I say you are 170, I am inaccurate. No, inaccurate. In fact, I am very inaccurate.
But maybe in the future.
Unlikely, I'm sorry. Most girls have their full height by your age. I don't think you will grow anymore. Sorry, that is not true. You will not grow vertically anymore, but diet dependent, you could grow horizontally.
You will grow 15 more centimeters. So.
Don't lie to her. Don't give her false hope.
Wear heels.
Yeah, just do what Lorraine does. If you're not happy, wear heels.
I don't know how to wear that.
Oh, that's a problem. You'll need to practice
Then
that.
you are still a girl, not a woman.
I don't know how to make up. I don't know how to wear sexy clothes.
You just put them on. It's not that difficult.
Frank, it's okay. You are an engineering student. You don't need to worry about this. You're an engineering student. You only need pen, paper, and your umbrella, and you have everything.
Yeah.
Yes, you have everything. That's all you need in life. Okay, next slide. Oh.
Yeah, you missed it.
Sleepy?
But you guys went to the gym. Why are you sleeping?
What do you mean, why?
They're all tapped out from the gym.
No, when I usually go to the gym in the middle of the day, I'm more. That's me. I'm weird like that.
You're different. Some might even say special.
Yes, I'm different.
Go on! You have this?
Yeah.
Okay, next. Error is the difference between a measurement and the true value. Error does not include mistakes. Now that's important. So if you get the wrong answer because you did something stupid, that's a mistake, not an error. Values that result from reading the wrong value or making some other stupid mistake should be explained. So for example, if I said Fuang is 180 centimeters, that's not an error, that's a mistake. Why? What happened? Huh?
What's your explanation?
Yeah, what's my explanation? Peer pressure. I was pressured into giving this value. Yeah. And excluded from the data. So then you exclude it. So when you're doing your report, if you get some really stupid answer, like the speed of the trolley is 150 meters per second, that's a mistake. What's the mistake? Maybe you forgot the decimal point. What do? You exclude it. Question?
Exclude it from where and write the explanation down where we're excluding it.
I suppose in the analysis section, because technically the first step of in the sort of process of analysis, like a sort of pre-analysis step, is what you might call data cleanup. This isn't something we have to worry about in physics unless we made a mistake. So technically it would be in the analysis section, I suppose, at the beginning of it saying the following were excluded from the analysis because blah.
And then we remove them from the tables and graphs, and this is when we are excluding them?
You can remove them, but I personally feel like they shouldn't be removed from existence and will probably put it in some kind of appendix at the back. There's a difference between not including something in your analysis and then deleting it from history.
Yeah.
So I feel like it should not be deleted from history. Okay. Error is what causes values to differ when measurements is repeated. So when you do something the same way twice, it should have the same answer. If it's a little different, this is normal, this is called error. And none of the results are better than any other result. Although it is not possible to cancel error, you can control it and make it smaller. Often more error goes into determining the error or uncertainty in the measurement than performing the measurement itself. So in other words, what I'm trying to say is it's sometimes difficult to calculate the error and the uncertainty. In fact, sometimes it's more difficult to calculate the error and the uncertainty than the actual answer. And we'll see this in the next class when we get to use Excel. Yeah? Okay. So what do you need from this? At least the definition of error, please. Error is the difference between a measurement and the true value of the measurement. Did you write that down? Very good. Did you write that down, Omar? Are you sure? Okay.
Get out of my head.
Please, it's just too hot. Now, does anyone remember from your chemistry what a systematic error is?
Something to do with instruments used.
Typically, yeah, but how so?
Faulty.
No. What I mean to say is, what does a systematic error look like in your data? How does it affect your data?
All the data moves to one side.
Yeah. A systematic error is usually something maybe with the machine. It means all your data is off by the same amount. So what would be examples that cause systematic error? Well, one classic example is when you use the meter stick, you don't start at 0, you start at 1. This means all your answers are wrong by 1 centimeter. What's another classic systematic error? How? Yeah, but that means each. Well, no, it could be. Yeah, but that's more a human error.
What about the amendment?
How?
Move.
Yeah, that's not a systematic error. That's just an error, normal error.
Faulty thermometer.
Yeah. The other one I was thinking of is the weighing scales. It's not at 0 at the beginning.
Yes.
That's another one. Anyways, they cause all the measurements to be moved in a constant direction. As Michael said, move to the left or to the right or something like that. In a predictable way. So meaning all the answers are wrong by plus 1 centimeter, for example. The causes may be known or unknown, but should always be correct when present. So if you can see a systematic error, like everything is wrong by 1 centimeter, you can correct it.
How would we know?
You might not know. I think it will come clear when you're doing your analysis. But this is why it's important to write your procedure clearly. So if you wrote in the procedure, first you place the 1 mark at the top of the pendulum, and you know what I mean? You can know it this way if you keep good notes. Sleepy time. For instance,
Make them 5.
what?
Just don't remind me. Just don't remind me.
Make them 5?
4. For instance.
Make them 5.
I've heard some really bad jokes in my life. That has to be one of the worst. Now, I'm not saying it is the worst, but it's right down there. Right down there.
You're just jealous, you can't make such cool things.
Really. Really, yes. I'm so jealous right now. Look at me turning green. Right. For instance, no instrument can ever be calibrated perfectly. So when a group of measurements systematically differ from the value of a standard reference specimen, an adjustment in the value should be made. So an example would be, please listen, what's wrong for? For example, you know the weighing scales, what should it say at the beginning? 0. And then when you put 1 kilogram on it, what should it say?
1 kilogram.
1 kilogram. If it doesn't, you can adjust it. Do you understand? Now, you didn't really have to do that in your experiments, except for the ammeter and the voltmeter. What should they say at the beginning before the circuit is on?
0.
It should say 0 and 0. And did they say 0? They did. So it's okay. Systematic error can be corrected only when the true value is known. This means when you have some kind of specimen. Can I continue? So again, the first sentence is enough. Did you write this down, Ron? The first sentence? Very good. Sleepy boys. Come on, hang in there, Andrew. Alright. Continue. Random error is part of the total error. Basically, random error, a good example of random error is, do you remember when you were doing the voltage and the current? You noticed that the numbers were changing, up, down, up, down, up, down. This is called random error. What else had random error in the experiments? Remember with the laser in the water? The laser in the water was...
The water was not stable.
It was moving, yeah. How long did you spend in the gym? 2 hours. 2 hours. 2 hours of sitting down doing nothing in the gym. You don't expect me to believe you were working out for the full 2 hours, do you?
No breaks.
Really? Really? Are you counting sauna time in that 2 hours?
What?
Sauna?
They don't have.
I wish.
Which gym is this?
Like this.
Is that the one on Camden Street?
There is a branch over there. There is a branch right over here in Portobello.
How much is it?
29 per month.
And how long do you expect to see results?
How long?
Until you expect to see results?
That is expensive.
I've gained a kg already.
Did you?
Oh, no, it's supposed to.
There, really? That's disturbing.
Can do it with my butt too.
TMI! 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 Red card! NSFW! NSFW! Or should I say NSFS? So sorry, how long until the results are expected?
2 months ago.
2 months ago. You're not going to be one of those people that post before and after pictures on Facebook, are you? Oh, good.
He's doing it on Instagram.
Facebook, oh, how old-fashioned of me.
I'm not doing it for the image, I'm just doing it.
Yeah, that's what all those people in the gym say. You're doing it for personal self-actualization reasons.
No, just to kill time.
Not to crack open an old physics book for 2 hours, no. Yeah, well, you just know when it comes to the exams in the summer, you are going to ace the gym exam. This is where you're going to get the bulk of your points for college admission, is it? Alright. Do you have this? Yep. Trueness is how close the average value from your experiment is and the true value.
Is that an actual word?
Trueness is, yes?
Trueness.
Trueness is an actual word. Yes.
Is it like nervousness, trueness? Or that's just one word, trueness?
Yeah, the trueness.
No.
Yeah, trueness means like the truth value of something.
Yeah, it's a suffix.
Yeah, ness at the end of true as a suffix.
Wrong.
No, you seem confused.
No, it
Why?
seems wrong.
Why?
It's like true,
Yeah?
wouldn't it be honesty?
Yeah.
Is the honest value?
I get that. It's the context, really. Honesty implies deceit, and that means that the agent has to be intelligent. Whereas trueness, it has the same meaning as honesty, but it would be inappropriate to use honesty because measurements are not rational agents. The measurements aren't trying to deceive you. So we can't say the honesty of the measurement. We could say the honesty of the person performing the measurement, but we can't say the honesty of the measurement. We can say the trueness of the measurement. So the difference is reflecting the fact that measurements are not rational agents, whereas...
what's the difference between this and accuracy?
Accuracy? The difference is, this is when you average your values. Accuracy is for like one. So it's the difference between singular and plural, really.
It's also like the word humble. Only recently I found out that you can say humbleness.
Oh, really?
Really?
Yeah, exactly. Normally it's humility. It's not humbleness, but I just found out trueness.
Humbleness. I do wonder if humbleness is an example of people using it so much that it became a word. Do you know what I mean? Like,
It could be.
like you have, what do you call the person who unites two people? So using unite,
Power Ranger.
No, thank you. Using unite as the root word, what would you call a person who unites two people or whatever? Uniter, no.
Unity?
No. Unifier.
Yeah.
Oh yeah.
But I think enough people have said uniter, that uniter is a word as well. But really, it should be unifier. So I do wonder if humbleness is an example of this. I don't know.
But trueness is an actual, like...
Yeah, it isn't a fake word that just came into existence because of people's misuse. You see trueness much more in philosophy, you know, the truth value of something. Okay, you got that? Fong, you do not like this. The terminology is very similar to accuracy, as noted by Faisal, but trueness applies to average, whereas accuracy applies to 1. Bias is the difference between the average and the true. So, what do we call the difference between the true value and the measurement? We call that error, and we have different types of error: random error, systematic error. When you have an average, we call it trueness instead of accuracy, and the difference between the average and the true value is not called error, we now call it bias. So all these wonderful, wonderful, complicated terms, which none of you will use correctly in your lab report.
Hater.
Huh?
Hater.
Not a hater. I'm being realistic.
Hater. Just hate us because you're not us. They hate me because they hate me.
I'll use that. Huh? No, I'd say the first sentence and then this sentence with bias. Bias is the difference between the average and the true. Bias is the difference between the average value and the true value. TME? Too much English? TME?
TTYL.
Too much English? No? What?
TTYL.
TTYL.
Talk to you later.
Alligator.
Terrible.
Are we getting a 10 minutes break after the 13th slide?
I think I have bad news. I think there's more than 13 slides. I think that's misnumbered.
No.
Possibly.
No, it's not.
But sometimes I'm misnumbered.
But this is not.
How do you know it's not?
Because this one reads topic and the date and how many slides there is.
But that's sometimes wrong.
We don't write the slides down.
No, that number is automatically generated.
Yeah, exactly.
But I need to compile the slides twice for it to be updated. So for example, if I add to it but don't recompile it, then it'll keep the old count.
Doesn't matter.
No, due to uses the program, due to doesn't.
No. It doesn't matter how many slides there are. It's just the same question. Will we get a 10 minutes break after the last slide or this?
Whatever number slide that is.
Yeah.
Perhaps.
Question.
No, I'm let me finish first, please. Now, bias is the same thing as total systematic error. Okay, I don't really need that. That's okay. Right. Precision is how close your independent measurements are. Let me give you an example. Wait. When you did the pendulum experiment twice, remember each time you did it twice? each time you should get the same number. So, for example, the first time you did it, you got 20 seconds. The second time you did it, you should get 20 seconds. Then next time should be like 18 and 18, and then 16 and 16. But that's not what happened. The first time you got 20.1, and then maybe the second time you got 20.5. Remember? Precision is how close those two measurements are. Those two measurements that should be the same. Do you understand?
What about 17 and 17.9, 09 and then 16.19?
Yeah, so then the precision is like 0.2 or whatever. It's the difference between the two measurements that should be the same. Why should they be the same? Or well, it's the closeness between independent measurements under the same conditions. So if you do the same things, you should get the same value. Precision is how close they are. But I think these are all words you know from Lorraine's class.
Yeah.
Sorry, these are all words that Lorraine tried to teach you in chemistry class.
Yeah. I asked her, then she.
Huh?
I asked her, then she explained it.
So we're cool with this?
Yeah.
Cool with this?
Yeah.
Do you have less classes to teach now?
Yeah, but there's exams I have to do this week, like monitor, you know. And like I said, I don't mind that.
Oh yeah, I wanted to ask you.
It's only the listening exam that drives me crazy.
Because they changed our...
You have 30 seconds to check your answers. Section 2 will begin shortly.
Because they changed...
You will hear the lecture twice. Yeah, go on.
Oh shit.
Because they changed our timetable.
Yeah,
And they cancelled the EAP for this week.
yeah.
Tomorrow we have physics at 1 and then...
Stop right there. My students have their physics exam tomorrow at 1. So I will be in this exam.
So we start at 2?
No, 3.
No,
Why
three.
3? I'll finish at 5. What?
Yeah.
I'd rather not come. Yeah, I'd rather
Wait.
not.
So
I
this
thought I
is-
had it at 1. Or maybe I don't. Maybe it's later.
No, we need to know.
No, I'm sorry. I'm wrong. Tomorrow's only Wednesday. I have the physics on Thursday, I think. What's your question? You want to move something, is it?
Yeah, because we are free until 3. I mean, we
What?
don't have anything. We have physics at 1 and then a break for an hour and then math at 3.
Yeah.
So can we bring the math up or take the physics down?
You want the triple.
Oh no, no triples. No triples. Could we, do you have anything at 9 o'clock?
We're not coming.
Yeah.
We have EAP at 9 o'clock.
Well, this is the best I can do. I can do the class at 9.
Then we will have like...
The way it is.
Okay,
Then
fine.
we'll have like 5 hours break.
Would you have that long? No, because if you have physics, if you had 9 and 10, then you're free at 11 and 12. Then you have me at 1, and then you go home, is it?
That's the only thing, man.
Yeah.
No, it's very nice like this.
You've changed your mind? Does this Faisal speak for everyone?
No, I want 9.
Yeah, I thought maybe someone
Habibti,
would.
I'll come alone. At 9, you have the lesson. At 9.
But finish early too.
You're still finishing
We
at
start
the
early,
same
we
time.
finish early.
Listen, bro, I want to sleep at night. I wake up at 6 every day so that I can come here before 9.
You want to sleep, huh?
Yes.
Make it 10.
It's like normal.
Hang on, let's see. Does anyone really feel strongly about 9 o'clock tomorrow?
So
Who wants to have a lesson at 9 o'clock?
Can you move the physics lesson or the single lesson at 1?
To when?
Can you move it like 12 or something?
So then you have
an hour
you have a
between.
break. You have an hour.
You already have an hour. You have class at 1, then you have a break at 2, and then you have a double at 3. So you already have a break tomorrow.
Yeah, I know. I mean, like we can finish at 2. Start at 9, finish at 2 hours a day.
Yeah, so that means have the 2 hours at
No.
9 o'clock. He really doesn't want to wake up for 9 o'clock. You're okay with this?
Yes.
And you're okay with this? No, you do mind, because you have trouble getting here for 9 o'clock, don't you? No, you're actually okay.
Yeah.
You sometimes have trouble for 9 o'clock.
No.
I do.
A little bit. Sometimes.
Do you guys want to sleep more?
But then could we take the physics class as well? Because one break would be enough. Because we have to...
9,
10, 11 breaks.
Stop altering the timeline, guys.
You know what? This
Don't bother. We'll just have it as the timetable.
We'll just have it as the timetable, because I don't even know if I'm free at 9 o'clock anyway. Because I could be doing some stupid biology exam at 9 o'clock or whatever.
Biology, you don't have to know.
I know I don't teach biology, but maybe I'm the one who has to do the exam for the students.
Give up.
Sit in class and look at
Give up.
Yeah.
No!
I swear it's just to irritate me. It's not for herself, I swear.
I like her style. Right. So did you write that sentence down? Precision.
Yes.
Yes? Okay. I don't think you need all of this. Finally, I hope. Uncertainty. Basically, uncertainty is what you put with your measurement to represent how much it could be wrong by. So, for example, the uncertainty needs to address errors from all possible effects, both systematic and random, and therefore it can help express the accuracy of the results. So, in other words, your uncertainty needs to consider everything that could go wrong and put a number to that. And you are saying Andrew is 1.8 meters tall, plus or minus 1 centimeter. You are saying I've considered everything that maybe is wrong, and I'm confident to say his true height is between 1.79 and 1.81. So uncertainty is a statement about where the true value is. So you need to be confident that what you pick for the uncertainty, that the true value is likely between the two. Now, you can make uncertainty as big as you like. For example, if I said Andrew's height is 1.8 meters, plus or minus 1 kilometer, is the true value in this range? Definitely. But that's useless, because you're saying, I don't know his height. It could be anywhere between minus 1 kilometer and plus 1 kilometer.
Minus 1.
Exactly. So, your goal is to make uncertainty small, but not so small that you miss the true answer. Do you understand? No, you don't understand. Okay. Your height is 148 centimeters. No, sorry, what did you say?
58.
Sorry, 158 centimeters. So if I say her height is 158 centimeters plus or minus 1 centimeter, I am saying she is definitely between 157 and 159. Yes? Okay. Fuang's height is 158 plus or minus 2 centimeters. So I'm saying her height could be between 156 and 160.
Why 156?
Because I said plus or minus 2.
Oh.
Yeah?
Yes.
But if 156 is lower,
But if 160, it's higher.
how much?
Not much, but it's something. Do you understand? Now, in chemistry, did you have... No, you did have to calculate uncertainty in chemistry, using the formula I gave you last time. Now, in one of the physics classes this week, I want to show you how to use Excel to calculate uncertainty.
I have now.
I don't know if everyone has their laptop.
I think.
Who has their laptop? You have it? Do you have it? No. You have it?
I have.
You have it? Have it? Have it?
But
Have it?
you're gonna show us how to do something, yeah?
In Excel.
Yes, I can just like
Why?
look at these.
Do you know how to use it? You do not know how to use a Chinese laptop. What nationality are you? Right.
He doesn't know how to get the formulas on Excel, that's what
My Chinese student does not know how to use the Chinese laptop because it's in Chinese.
Even Chinese is confusing for Chinese.
I don't know the program. How to use.
But I thought you said that we will do it during the ICT exam.
That's what I was going to do on Friday. Yeah.
Won't be here.
What about it?
Yeah, that's why I want you to do it on that side.
Can I go make my coffee? Well, because I was discussing this.
Okay, but just before you go, would you like to do the Excel now, or do you want to wait till Friday? Because your choices are this. You have two choices right now. You can either start working on your lab report, or you can do the Excel lesson now instead of on Friday. In both cases, you're working on your laptop.
But I thought in Friday we have the practicing presentation.
You're right, because now you have it after the holiday. Okay, we'll do Excel now. You can take a 5-minute break. You're going to make your cappuccino.